Our next speaker on the pioneer stage is Troels Schönfeldt. Nova, can you explain us how Troels is changing the industry of energy forever?
Our next speaker is rethinking nuclear energy completely. He is building a fundamentally new type of reactor that cannot be weaponized, that can convert waste into energy, and cannot result in disasters. He is on a mission to deliver a scalable, cheaper than coal, dispatchable power source. Please welcome to the stage, tuning in live from Denmark, co-founder and CEO of Seaborg Technologies, Troels Schönfeldt.
Troels, the stage is yours.
Thank you. So yeah, I'm Troels Schönfeldt from Seaborg Technologies, and as I was introduced, we are working to change the energy market and decarbonize the world with nuclear technology. So Seaborg Technologies, rethinking nuclear. So first off, just to put things in perspective, global warming is the most existential crisis that humanity has faced so far. And I don't think we fully understand the issue as people here on the planet. What we're looking at is especially Southeast Asia, where they have huge regions with no access to wind or solar, simply due to climate. So no wind near equator and a lot of clouds on jungle islands. And they don't have any rivers. So they cannot rely on the renewables that we can rely on here in Europe, or at least to some extent rely on here in Europe. So they have an issue. They are running out of water, and they do want more industry. So they really need energy. So these days they are building coal and gas like there's no tomorrow. And if they don't find an alternative, I don't think there will be too much of a tomorrow. Because we really need to decarbonize as a planet. But on the other hand, we also need industry, and we need food and water. So you can't really blame these guys for installing more energy. And that's fundamentally the issue we try to solve by coming in with a nuclear technology that can provide cheap, sustainable energy for these grids in these regions. So what is our fundamental hypothesis here? I grew up many years ago, and in a world where we were polluting a lot. And today we live in a world where everybody is talking about pollution, but we are still polluting a lot. If you look at the numbers, nothing have changed. We have talked about decarbonizing for a couple of decades and getting rid of pollution for even more decades. So the fundamental hypothesis behind Seaborg is that that we cannot decarbonize if the money doesn't follow. So we need technologies that are cheap and deliver a good product to the end user. So the end user will get cheaper electricity, the investor will earn more money, and we will earn money as the manufacturer. Otherwise, we wouldn't be able to solve the climate targets. So that's the fundamental hypothesis. So we are basically trying to outcompete fossil fuels on market terms. That's kind of the fundamental hypothesis here. I'll also say that the shipyards out here on the right is very important for us, because there are many technologies that could be developed, but it's very fundamental that it scales at an insane speed. And if by using shipyards, we can actually achieve these very high scaling rates very early in the process, because the shipyards can already build these technologies. So that's quite important. I won't talk too much about technology in this talk, but if you are to take one thing from this talk and from what we do, we are designing a fundamentally new type of nuclear reactor. And the magic in this technology is in the salt, because it's a liquid salt reactor. And the salt, it melts at around 500 degrees centigrade, and we can pump it into a nuclear reactor and create a lot of energy. The magic here is that the salt is, I actually have some here. It's basically a rock. This you can buy in healing stores. So that means if you have a nuclear accident, today you would have a gas cloud leaking, but in our reactors, you would have a liquid rock that comes out and solidifies. So you can contain the accident on the same site. And this is due to the salt, because it's a salt, but it doesn't release any gases. It doesn't dissolve into water. And then obviously it can carry the fuel. So all these radioactive elements are contained in the salt. It's very important. That means that our technology is fundamentally safe, no matter what accident you imagine. Even if you imagine acts of war or terrorism that explodes this power plant, the radioactive is contained within the radius of the explosion. So even if you actively explode it, it won't pose a risk to neighboring people. It's very important. And it changes everything around nuclear, because nuclear is one of few green technologies today that can scale and then can deliver a lot of energy. But the problem is the safety. And in making these gaseous and radioactive materials contained inside the nuclear reactor, we have to impose a lot of engineering solutions. And when we do that, we add systems that adds cost. That means that nuclear today is not really economically compatible with other technologies. So that's the fundamental problem. By making safety a natural feature, it becomes fundamental, and it kind of makes everything simpler. Thus, it makes it cheaper. Thus, it makes it easier to scale out in the world. So what are we designing here? We're designing a reactor, which you actually see here on the right, which is not very large. It contains the salt that creates energy. It cannot melt down or explode. As I explained, it cannot release radioactive gases to air or water because these are captured in the salt. And then it cannot be used for nuclear weapons, which is fundamental if you want to engage in especially developing countries who needs the most energy in the future. And then we can operate for 12 years without refueling. That doesn't sound too important if you're in Europe, but if you are in these developing regions, there's a lot of poor logistics regions where it's very hard today to provide energy. So you can't have hospitals, you can't have clean water because you cannot provide energy, because the energy would require you to transport fuel and have a big logistics network. And you cannot even build the logistics network before you have the energy. So that's kind of a catch-22. So we can solve that by simply coming with a product here that delivers the energy and doesn't require refueling. So that's quite important. Also, I think it's an important remark that what we're doing here is actually not that new. There are new elements, but the technology itself was developed back in the 60s. And first it was developed in US. Actually, back in the 50s, it was tested first and then tested again in the US. And it's also been tested in China. So it's not entirely new, but there were really, really good reasons why it wasn't commercialized. Back then, there were technological barriers that couldn't be overcome. We believe we can overcome these today, and that's important. So I'm a physicist, and when we started this company, I started by calculating stuff and trying to figure out how stuff worked. But when you build a company, there are so many more things. So if you actually want to take something from idea to reality, there are so many things that you need. You cannot just calculate how the chain reaction works and look at the safety. You have to actually build a product, and that product requires a supply chain. And this is what we try to illustrate here. And part of why I think this technology has a really good competitive edge is that we can buy subcomponents, that is pumps and valves and other things around North Europe, where we're good at making advanced metal components. Then we can transport them to a small central factory we can assemble them into a reactor unit that we can then transport to the shipyards where they are really good at the big stuff, such as turbines and ships. We can install it there, and then we can ship it to where they need the energy. And where they need the energy is often not where you can process the steel. If you can process the steel, you most likely already have a lot of energy, or you for sure have a lot of energy. So the market is actually not the place where you can produce it. And a barge is a very, very good way to transport between these two. And that turns out to be a very, very hard challenge, except the physics is, of course, very challenging. But this building a business, building supply chains, building partnerships is a very, very big task. So we're building a floating power plant. Because we are doing it on a barge, we can use shipyards. And I guess most of you are from Europe, and in Europe we don't really see heavy industry. But if you go to the big shipyards in East Asia, you will see that they actually can build hundreds of ships per year. So if we can break through the barriers with this technology to market, we can actually go directly into serial production and produce hundreds of these power plants per year. And to put that in perspective, today there's 450 commercial nuclear power stations in the world. We believe that we could build 450 more every year. So we could double that every year from the beginning of this. Also, the energy market is a very, very slow moving market. So the coal plants that we plan today will only be built in 20 years. And we need to decarbonize faster. Again, here, shipyard come in. They have high quality, but they also have very, very reliable and fast delivery time, meaning when you order a power plant, it will actually be very fast to be there. So we can transform the energy market at a very, very fast speed, which is very important. And then, well, then we comes into business here, where it's like there's a lot of, when you build power stations, there's a huge dynamics around how you build the ownership of that, who will own it, who will buy it, who will be the customer, who will operate it, how will the electricity be sold, all of that. And there's a lot of things there, but in a shipyard, a lump sum contract is one of the ways, which is very attractive. I don't think this is the right place to go into details around this, but there's a lot of interesting aspects there. Another thing that you get from shipyards is that you become exceptionally modular. A ship is basically, well, three components. It's a middle and two ends. And one end people lift, the other end is just, well, the front of the ship. And in between the middle, we can put reactors, we can put turbines, we could put hydrogen production facilities, we can put more reactors and more turbines if we want. So it's really easy to adjust this to the need of the local market. So as a baseline, we want to produce 200 megawatts. If you do not know what that is probably 400,000 households in Europe or so. So that's a lot of energy. So we want to produce that in a barge, buy electricity for whatever you need. But we can easily build these larger. So, and this is a lot of what it comes down to as a startup. I think I once told some investors that we could build a reactor, and they believed us and gave us some money, but it turns out we can't. That's impossible. 5 physicists cannot build a reactor. What 5 physicists may be able to do, and what you as a founder may be able to do when you want something, is to build a team that can solve the problem. Building a reactor requires a lot of talent. Today we are more than 30 people, and we are actually hiring quite fast. We will probably be around 80 people by the end of the year, plus a bunch of interns and other associated with the project. And building a team like that requires a lot. That's actually, I think, the biggest challenge I have had in this venture has been building this team and learning something very, very much not physics, but very much into how people behave and how people function together and how you create the right framework for people to be able to work. And that's a very, very hard thing to do. But the gist here is that we're building a reactor. And I can't do it, and my co-founders can't do it, and the team we have now cannot do it. But maybe we can become good enough if we find the right team members to add to the team, and if we are good enough at learning from our mistakes, then we can become good enough and actually do this in the end. That's the philosophy. And it's really, really, really hard what we're doing. So we spend a lot of time on actually finding the right people. And currently we attracted people from 5 continents. We are in Denmark, we have many Danes, but it's only something like half of the team that is from Denmark. Most is actually international. And then obviously we have spent a lot of time on building supply chains, especially out in Southeast Asia and East Asia, where they are very, very good with steel. And in nuclear, the regulatory approval is really, really a big thing. So I actually included a slide here. And I think this is one of the big things we have done, which was no small feat, is that since the nuclear regulatory system is very heavy and cumbersome and built around the existing reactors, it's very, very hard to do something new. So we figured out that we could apply another process to this. And instead of using the nuclear regulatory framework, we use a maritime regulatory framework. We are complying to the same rules. We are living up to the same standards and all of that, but we are using a new framework. And that combines the word innovation with the word regulatory there, and that's almost impossible. But in doing so, we actually managed to become the first advanced nuclear reactor that have ever received any form of commercial approval, which is really, really nice. It also means we are on a track where we could be in the market by 2025, which is very, very soon in the energy market. If you want to buy a wind turbine farm and you pay for it today, it won't be ready by 2025. So it's actually that's a very short timeline in the energy market. Also, another thing you have to think about when becoming an entrepreneur is the customer. So you have to build a product that people want. And I won't go too deep into this, but there's a lot of things to consider there. Like, how are the manufacturing happening? Who is manufacturing? What is the reliability in delivery? How is the investment contract built up? For me, the bottom line here, and it's also in the bottom here, is that we are reducing the CO2 drastically. We are also going to be very, very cheap compared to other technologies, which is why people would pick this technology, or one reason. But the bottom line here is the CO2 reduction. And with that, I'll just round off and say a little bit about our ambition here in the last couple of minutes. So the energy market is gigantic. It's mind-boggling big. Whenever you spend €1, something like 10 cents goes into the energy market somewhere. So it's a really, really big market. And it's expanding really, really, really fast. And we need 10 times as much energy in 20 years on this planet. So the energy market is big. And there's no lack of investments. The only thing is there's no alternative to coal and gas in huge regions of the world, actually in most of this planet. So gas and coal is being expanded dramatically. Also, we actually do have the existing supply chains to produce and manufacture this and deploy this. What we don't have is the technology. And if we can break through that barrier, get the technology ready and get the right approvals, then we can tap into all of these elements and make an enormous shift in the entire energy market towards green energy with no political influence. We can just do this because it's best for everyone. And looking a little bit holistic of it, it is as a rich Western world, it is our responsibility to develop these technologies needed to power the world. And what we're trying to do is develop in Denmark, where we're good at that, produce it in South Korea, where they are really, really good at manufacturing, and then power everywhere in the world, starting with Southeast Asia. And if we just look at what they're building today in Southeast Asia, they are planning to build what would correspond to 8,975 of our reactors. They are planning to build that for over the next 20 years. This will come from coal and gas, and it absolutely needs to be replaced. So the opportunity here is massive, but the responsibility is also massive. This is something we as a planet has to solve, and we cannot get necessarily the people without energy to solve these issues. And with that, I will just say enjoy the rest of the event.
Thank you, Troels, for this amazing speech, because climate is so important, and thank you for inspiring the next generation of young entrepreneurs. I think we really need that, to hear that more, how important climate is. Before we're letting you back to work, I have a final few questions to ask you. Were you always interested in energy, and where does this specific interest comes from?
No, I was never interested in energy when I was smaller. I didn't understand what it was. It's something that came when I became older and became a physicist. As a physicist, you should be interested a little bit in energy, and realized how fundamental it is. Mm-hmm. The world as we live in it now, it's basically, we have some science, especially material science, that progresses our technology, and then we have an amount of energy available. There's also money, but that's actually just a tool for governing this. What we have today is energy and science. That's the fundamental drivers of society. And I really think energy is the most fundamental resource we have on this planet. And currently today, there's 1 billion people with enough. And over the next few decades, there will be something like 8 billion that will be with way too little energy or even no energy if nobody reacts. So we absolutely need to provide energy for the entire world and not just for Europe and a couple of other places.
Absolutely. And why is Seaborg Technologies actually ahead of TerraPower? What is Seaborg's strength?
I don't know if we're ahead of TerraPower. I think TerraPower is doing something differently. As I said, the technology has been actually tested before, so there's nothing new in that. But there were reasons why it was shut down. Actually, a guy called Seaborg was very heavily involved in stopping the experiments. And we are called Seaborg, so we don't think he was stupid. And TerraPower solution is one solution. That is the component that does work without being too technical is the moderator. TerraPower says we can build a reactor without a moderator. That gives you some upsides and some downsides and some new technical challenges. We are saying we can actually use a different moderator than what they thought they could use back then. And that gives us some technical challenges. So I don't know if we are in front of them. I think we have a different solution. I would subscribe to our solution, but I do really think this is a nut that needs to be cracked. So we should actually try to solve this in any way possible. And I really hope they have success. And I obviously also hope we have.
Of course. And what's the next goal for you when it comes to energy? What do you hope for in the future? How it will evolve?
Well, firstly, I hope it'll become green, and I hope we'll get way more of it, way more of it, because energy is, as I said, the fundamental resource. So I hope even in the Western world we'll expand our energy, and I hope that especially the developing world will get more energy. But I do know that if we do that on the pathway we are on as a planet today, the world will burn, and there won't be a tomorrow. So we have to do it in a new way. So my vision here and our hope is that and that's not only our solution, there's a lot of different ways to approach this, but I hope that everyone thinks about how they can help. And if they have innovative ideas, they should try to make them real, either by joining a big corporate or by joining a startup or by making their own startup or just by doing it in their kitchen. Whatever, we need to solve these issues. Does that make sense?
Yeah, we need to solve it together. You are a self-made entrepreneur. What was for you what is the most difficult part for you at being an entrepreneur?
It's a good question. To be fair, I didn't know what I was doing. We were very drunk. One night we were brewing beer for a few years, and we got so good at brewing that we could get really, really drunk. So we were really, really drunk. And most people wake up with a hangover. I did too, but I also woke up with a company, and I had no idea what I was doing. I had no idea. So there's just a lot to learn. And this, I learned a lot at university, and I learned a lot doing my PhD. But during my entrepreneurial year, I have learned way more. I mean, it's not even comparable. You learn so much in so short time. And as soon as you're done learning it, it's obsolete, because then the problem is solved and there's 10 new problems. You wake up every day and there's a fire. And when you go to bed, you're not even done extinguishing that fire. A new fire has appeared. And you just have to go to bed anyway, right? Eventually. So there's so many new things all the time. And you realize that physics is only a really small fraction of it. I don't do anything technical anymore. I just try to make the framework right for the team, but also finding investors and building supply chains. And there's a lot.
So it never stops. But you're not the first to say that the great idea came from a bar. You're not the first speaker here on the show to say that
No.
it came to life in a bar. What's the best decision you made so far?
I think that was that night, founding Seaborg. That's the best decision I made in my life. It's also the hardest and most hardcore decision. And anyone in the crowd, I would really strongly encourage you and advise you never ever to try something like it. But simultaneously, I would encourage everybody to try something like it, because there's nothing better and nothing worse. So it's figure it out. But I think that was the best decision. I feel like I live with my heart, and that I'm doing what I want, and that I'm doing something that I want to achieve.
You're doing something with passion.
Yes. And also I feel like some guy is standing there just punching me in the stomach every day, and it's hard to keep standing, right?
How do you discover new opportunities in an ever-changing market?
Whoa. Well, I can't really tell you that, because I never did. This opportunity basically came to us, right? We stumbled upon it, we were reading up on it, we fell in love with it, and we thought we could do the physics. And then it turns out that we can probably do more than the physics. And then it turns out that we can probably also hire some people, because we found investors. And then, it's on autopilot, a lot of it. You're really fighting for it every day, but a lot of it is on autopilot. And so I never went and looked for a new market opportunity. It just struck us. And then we were really, really lucky, because we had no idea, as I said, we had no idea what we were doing. So we didn't know about what a market was. We just made some choices, and they turned out to be really well fit for the market. And then as you grow, you hire experts that know way more than you do about this, which is pretty easy. And they can spot these opportunities. So you'll have to ask them how you spot these opportunities. But for me, it was just luck.
That was actually my next question. How much luck is there in being a good entrepreneur?
I don't know, between 1 and 99%. There are many times, especially in our early history, where luck was fundamental. We took some choices without knowing, sometimes for other reasons, and they turned out to be just exactly right. Sometimes just because we didn't know better, so we did it wrong, and then that turns out to be the right decision. That's pretty much luck. Running into the right people, having the right timing. We didn't even get the idea. It struck us, right? So I would call it mainly luck and hard work. A lot of hard work. And luck is also something you position yourself for, right? You need to put yourself in a position where if luck appears, you can catch it.
Yeah, but you believe in luck. That's great. Do you have any final words of advice to our students at home?
No, actually, just figure it out. There's global warming is not the only challenge we face, but it is a really big one. And go and figure out some of them, and help with what you can help with.
But is there something that you would hoped for that someone had learned you when you were younger as a student, that someone would have something that they would have said to you that you had to discover by yourself, but that you would have loved to have known when you were a student?
No, I just wish I drank more beer.
Okay. We'll go out with that message. Thank you so much, Troels, for this inspiring talk. And I hope every project you do will succeed, and stay safe.
Thank you, you too, and enjoy.
Thank you.